This video is about quadratic inequalities, but I actually want to start with a more general discussion of continuous functions and their zeros. So let's start by drawing a graph. So I'm going to draw a function, and it's not going to be a quadratic function. Maybe it'll look something like this here, okay, and we'll call it f of x. And then if you look, you see there are three zeros of this function. There's one here, and the last one is right there. And I'll call them A, B, and C. Okay. Now what I want to draw your attention to is the fact that in between A and B, the function is always positive. Okay. In particular, it never changes sign. It's positive at one point, it's positive at every point between A and B. In between B and C, it's always negative, right? And more importantly, it never changes sign. It's negative at one point, it's negative at every point. Beyond C, as I get out here, notice again, it's always positive, right? And importantly, it never changes sign. We don't know exactly what this function is doing, but we can imagine it continues going up like that forever. And way back here to the left of A, it's always negative, right? It never changes sign. So this is a very, very useful result of continuous functions. Continuous function just means, in this case, the easy way to think about it is, as I draw it, I never lifted my pen. There are no holes, there are no jumps. It's just one continuous line. So the very useful result about continuous functions is the following. And I'll write it down. Continuous functions only change sign, right? They only go from positive to negative or from negative to positive at zeros of the function. And I want you to remember that because that's how we're going to answer all our quadratic inequalities questions. Continuous functions only change sign at zeros of the function. If it's positive at one point, it's positive everywhere in this section between two zeros. If it's negative at one point between two zeros, it's negative everywhere between two zeros. They only change signs at zeros of the function. Now let's take what we learned about the general continuous function and apply it to a quadratic function. So let's let q of x be x squared minus 2x minus 8. Now all quadratic functions are continuous, which is useful because every result we derive for continuous functions will work for quadratic functions. Alright, so what we want to do here is we want to find where q of x is positive and where it is negative. Alright, so for the general continuous function, the first thing I did after drawing it was to identify where the zeros were. And in this case, I was able to do it visually. For our quadratic function, we'll do it symbolically. So if you want to, hit pause and then identify the zeros of this quadratic functions. When you're done, hit play and we'll check your work. Okay, so let's check the work. So if I look at this, I notice that 2 times negative 4 is negative 8 there, and 2 plus negative 4 is negative 2 right there. So that means that this function factors as x plus 2 times x minus 4. Alright, so q of x can factor as x plus 2 times x minus 4, which means, of course, that the zeros are at negative 2 and positive 4. And I'll just write 4. Okay, there are two zeros that occur at negative 2 and positive 4. Alright, so what do we do with this information? Well, here's how I approach these types of questions. What I would do is I would write down a number line, and then mark off my zeros, right? And I'm not going to draw the whole, the two coordinate axes. I'll just do a number line, right? And we've got the location of our two zeros. And remember, for a continuous function, if it's positive anywhere in an interval between zeros, it must be positive everywhere in the interval. So to determine if the function, if q of x is positive or negative in this interval, we only have to test one point. And I'm going to suggest that we test the point 0, because 0 is very easy to plug into our quadratic function. Let's do it. Let's look at q of 0. That's 0 squared minus 2 times 0 minus 8. That's negative 8. So q of x is negative at the point 0. So q of x must be negative everywhere between negative 2 and positive 4. If it's negative at one point, it's negative at every point in this interval. We can also test this left portion here. We could try, for example, negative 3, q of negative 3. Alright, so that's negative 3 squared minus negative 2, minus 2 times negative 3 minus 8. Negative 3 squared is 9. Negative 2 times negative 3 is positive 6. And subtract the 8, and we get q of negative 3 is 7. That's greater than 0, so then q of x must be greater than 0 everywhere in this region. And finally, we can pick a point to the right, in the right interval, say 5. Now I'm going to do something a little different. Instead of using this multiplied out form of q of x, I'm just going to use the factored form. Right? If I use the factored form, I have 5 plus 2 times 5 minus 4, right? And I don't even need to do any more math, because that's obviously a positive number there, right? 5 plus 2 is 7, that's positive. 5 minus 4 is a positive number there. So I have a positive number times a positive number. That gives me a positive value. Remember, I don't care so much what the values are. I just want to know if they're positive or negative, because if it's positive at any point in this interval, it's positive everywhere. And when we do another example of quadratic inequalities, I will use this method again so you can see how useful it really is. So we know that q of x is going to be positive in the region to the right of 4. Okay, so we can take this information now and actually answer the question. We got all the pieces there, but we should actually endeavor to answer the actual question, right? It wants to know, find where q of x is positive, so let's write that down in interval notation. So q of x is greater than 0 for x in the interval, well, it goes all the way to negative infinity, and it comes up and it approaches negative 2, but it never quite gets there because negative 2 is actually a 0 of the function, so I have to use an open bracket or an open parentheses. And then it's also positive in the region from 4, not including 4 of course, all the way up to positive infinity. So there we've identified where q of x is positive. And then q of x is negative for x in the interval negative 2 up to positive 4, but not including these endpoints, of course, because it's 0 at negative 2 and positive 4. Alright, in the next video we'll do another example. Really look at some quadratic inequalities where we aren't looking at positive or negative.